Today I'm going to explain the cooling system on my 2002 Chevy Cavalier. Start with this side. There's our surge tank, and it's a 15 psi system. We got a couple bypass hoses right here. It's got a level sensor right there. Okay. One of the hose comes from the top rat hose, and the other comes from the low rat hose. We also got a hose connecting the tank to the low rat hose right there. Okay. It's only got one coolant fan because it's got no AC on it. And moving on to this side, here's our upper rat hose. Okay. So the hot coolant from this side, top of the engine, comes through here and the top rat hose and goes on top of the radiator, where it goes through the radiator and through convection. The cool air passing through the radiator fins cools it down. From there it goes at the bottom of the rad, where it's sucked through that rad hose and through there by this pump. So this water pump is driven by the serpentine belt. And we can also see a weep hole on this pump right there, and it's not leaking, which is a good thing. So this pump, being a positive displacement pump, it's always creating low pressure into that hose, but it's got a thermostat restricting the flow. So to complete the flow and prevent cavitation inside the impeller of the pump, we got a bypass hose right here to complete the cycle. So this bypass hose goes all the way through the side of the engine and all the way back right here. Right there. You can see two hoses going directly. That's a better. Two hoses going directly into the firewall. So these two hoses are for the heater core inside the passenger compartment. So the heater core gets hot coolant from one of the hoses, which is connected to the upper rat hose right here. So the hot coolant coming from the top of the engine goes through this hose at the back and through the heater core. It cools down a bit if the fan is running and providing heat in the compartment. Otherwise it just goes through that and cycles it back and blows hot coolant directly onto the thermostat, which helps us to heat up the engine quick by blocking the thermostat, and to maintain the engine temperature by opening the thermostat when the required temperature is reached. Okay. Those are the major coolant lines. So the coolant flows through the water pump into the jackets in the head, into the engine block, and heats up and flows through there and comes up top and goes back into the radiator. And when the engine is hot enough, the thermostat opens and allows the coolant flow. But when optimal temperature is reached and it's exceeding, the PCM would like to turn the fan on. So it does that by this coolant temperature sensor on the upper rat hose. To explain that better, there's a diagram. So the engine coolant temperature. So the PCM sends a low reference to the coolant temperature sensor, which in turn sends a voltage signal. So the PCM decodes that voltage and sends a ground to the cooling fan relay, which is protected by 30 amp fuse outlet given, which gets power from 30 amp fuse. So the circuit side of the relay is turned on, which becomes a small electromagnet and pulls the switch side to turn on, which turns the cooling fan motor, and it's all protected by 30 amp fuse right there. To demonstrate that, so here's our cooling fan relay, and here's our cooling fan fuse. So that's 30 amp fuse. We need a big fuse for the motor. So I'll quickly explain the terminals on the relay. So 85 and 86 are control side, which is controlled by the PCM and small current by the PCM. 87 and 30 is the switch side, which is a big current and big wire and 30 amp. So the 30 amp actually flows through 87 and 30. So I got a big wire here. So I would jump it quickly and try to turn on the fan right there. Jumped, and the fan is on. Okay. So the other things on this cooling system are, so if we have ever to do coolant system service on this vehicle, and you fill it up with fresh coolant, and to bleed it, you got a bleeder screw on this hose right there. Would open it and bleed the air out of the system. The other thing that this vehicle has is a block heater right there that would heat up the coolant in the water jackets in the engine block to reach the operating temperature faster in colder environments, but we don't need it in Vancouver at least. The other things with the cooling system is if they leak. So the common leak points on these cooling systems are these radiators. So the tank side on the radiator is made out of plastic, but the cooling side of the radiator is made of the aluminum, and they're joined together by these brackets, or the aluminum is joined on top of the plastic, which is not good because over time aluminum fatigue and it breaks or it leaks, which could cause a major coolant leak. The other coolant leak could cause by when the electrolysis happen inside the cooling system, when the coolant becomes too acidic and it eats out the metal or even the hoses. We can pressure test the system to check the coolant leaks, which makes it easier to detect the leaks. The other problem could be the thermostat is shut close. That would cause engine to heat up quickly, but it won't allow it to cool down. So even on idle, if the thermostat is stuck, it would cause the engine to overheat. So if the thermostat is slightly open and is stuck there, the engine would heat up relatively quickly, or it would heat up slowly, but as soon as you would give it some load, it would overheat because the flow is not complete, it's just slight opening. If the thermostat is completely open, the engine would take a long time to heat up and it would always remain below temperature. So these are some problems with the cooling system. The other problem is if the coolant pump impeller broke off, if it's made out of plastic and it just breaks, there would be no flow in the system, and it would just be hot coolant sitting inside the water jackets in the head. That would cause it to overheat pretty quickly. So that's all for today. I think that's good.